Hi everyone. Today, this is lesson 4.2. I'm going to talk about general annuities due. So our first lesson talked about simple annuities due. This is going to be very similar to that lesson. If you remember, the main difference between a simple annuity and a general annuity is that general annuities, their compounding frequency and the payment period are not the same. Okay, so one could be monthly, one could be semi-annually. So just like in the first lesson for an annuity due, remember, payments are due at the beginning of the period instead of the end, so there's one additional interest term that was added. The same thing applies for general annuities due. It's very minor changes to the formula, but the only difference is, you'll remember when I start talking about it in the next couple slides, that there was that interest term. Okay, so remember the equivalent interest rate. 1 plus I to the exponent c minus 1. Okay? So I always like to bring up this slide just to kind of see where we're at. Okay, so these are all the different types or major types of annuities. We'll talk about a few special cases after this lesson. So now we're going to talk about general annuities due. Okay, so payments are made at the beginning of the payment period, and the compounding frequency and payment period are not the same. So far we've talked about ordinary general annuities, ordinary simple annuities, and simple annuities due. So this is kind of the last piece of the puzzle for major forms of annuities. So I'm going to start right away with a formula. Okay, so just like in our last lesson, there's minor differences to these formulas. Okay, so for a general annuity due, remember, if it's a general annuity, your interest rate was now this term P. Okay, and remember, P was 1 plus your periodic interest rate, okay, to the exponent c minus 1. And remember, your ratio c was the number of interest compounding periods divided by the number of payment periods per year. So I'm going to go through a few examples, doing future value, present value, and then finding the payments, just like we did in lesson 4.1. I do want to emphasize this calculation though. So often I see a lot of mistakes made when you actually put these numbers in your calculator to solve this equivalent interest rate. And a lot of it seems to have to do with when your ratio C is a number less than 1. So let's say it's something like 0.166 bar, a repeating decimal, or 0.33 is a repeating decimal. Okay, those ones I have found that a lot of students have had problems. Okay, so just before we do that, I'm going to show you this formula. Okay, so the future value, and again, I use the term G for a general annuity as a subscript, and in brackets I write due, so you know it's a general annuity due. And that's equal to the payment times 1 plus P, your equivalent interest rate, to the exponent n minus 1. N is your total number of payment periods, divided by that same equivalent interest rate P. And then we have this additional term at the end, 1 plus P, and that's accounting for that one additional period of interest that you're going to have, because your payments start at the very beginning instead of at the end of each period. Okay, so when you first enter into a car lease, okay, if your payments are at the very start, then you have to put that money down up front. All right, so that's just one example. So let's look at the first example. So what is the accumulated value after 5 years of payments of $20,000 made at the beginning of each year if interest is 7% compounded quarterly? Again, looking at this, it's the beginning of the year. Okay, that's when your payments are, so it's annuities due. Your payments are yearly, and your interest is quarterly, so they're not the same. So that makes it a general annuity due. Okay, so the beginning makes it an annuity due, and the compounding frequency and payment period not being the same make it a general annuity. Okay, so this is asking for the accumulated value. Okay, so that means your total value at the end. So that means you're looking for the future value. Okay, so you can always start with the formula, future value. And again, I use this subscript G just to note that it's a general annuity. And then this brackets with due, and notice that it's an annuity due, just so you use the right formula. And that's equal to your payment times 1 plus this equivalent interest rate P to the exponent n minus 1 divided by P times its additional interest term, 1 plus P. Okay? So again, putting everything on the side here, what do you know? Well, from your question, your payments are $20,000. Your nominal interest rate, J, is 7%, which is 7 divided by 100, removing the percentage sign, or 0.07. Your number of interest compounding periods is quarterly, so that means M is 4. So your periodic interest rate, I, is equal to J divided by M, or 0.07 divided by 4, which gives you 0.0175. Okay? Next, you need your ratio, C, and that's equal to your number of interest periods per year divided by your number of payment periods per year. So interest is quarterly, so that's 4, divided by your number of payment periods per year. In this instance, it was the beginning of each year, so it's yearly, so that's 1. So 4 divided by 1 is just 4. So now, okay, your equivalent rate of interest, P, is 1 plus your periodic interest rate, I, to the exponent C minus 1. So that becomes 1 plus 0.0175 to the exponent 4 minus 1. Okay, so remember, you have to do your brackets first here, all right, when you're doing these. So you end up with P is equal to 1.0175 to the exponent 4 minus 1. Okay, then you have to do the exponent, so 1.0175 to the exponent 4, and then you subtract the 1 off at the very end. Okay, it's not subtracted from the exponent, it's done at the very end. And if you do that, you'll get a number of 0.07186. This number, okay, should always be a decimal. I've seen some students where they get an answer and P is something like 6.2, okay, or 6.8. It has to be a decimal like this, okay. It'll always come out as something less than 0, okay, because it's your equivalent interest rate. All right. The last term you need is N. Okay, in this instance, we have payments for 5 years, and they're at the end of each year, which means we're only making one payment a year. So N is 5. So now if I substitute all these values into this formula, our future value for a general annuity due is equal to our payments, 20,000, times 1 plus that equivalent rate of interest, 0.07186, and then to the exponent 5, our term N, minus 1, divided by that same equivalent rate of interest, 0.07186. And that's multiplied by 1 plus that equivalent rate of interest, 0.07186. Okay, so I'm going to do this in steps. Okay, so I'm going to do everything in the brackets first, just so you see what you should obtain with your calculator. So your future value is equal to 20,000 times everything in these brackets comes to 5.772, and then multiplied by your last bracket, 1.07186. Okay, I'm carrying a lot of decimals in this. I know some of you during your tests will carry even more. It could be 6, 7, 8, 9 decimals. You can do that, but you don't necessarily have to. Okay, you'll get a slightly different answer. You can keep it to, 2 or 3 or even 4 decimals instead of 7, 8, or 9, and that can save you some time when you're doing your tests. So if you do this, your final calculation, multiplying these 3 numbers together, you'll get $123,735.52. Okay, so that's your final future value after 5 years. Okay, let's look at a second example. Candace deposited $500 at the beginning of each quarter for 10 years into a savings account. What is the balance at the end of 10 years if interest is 6% per annum compounded monthly? Okay, so it's asking for the balance at the end. That's saying the future value. Okay. And next, okay, you'll notice that she made her deposits quarterly, but interest is compounded monthly. Okay, so that means it's a general annuity. But payments were at the beginning of each quarter. Okay, so that makes it a general annuity due. Okay, so that's kind of how you can reason through these questions to figure out which one you're dealing with. So again, now that we know we're looking for the future value, we can start with the formula. Payment times 1 plus that equivalent interest rate, P, to the exponent n minus 1, divided by the equivalent interest rate, P, times this additional interest factor, 1 plus P. Okay? Now again, starting with a list of the items that we know, her payments were given in the question. They were $500 each quarter. Her nominal interest rate, J, is 6%, which is 6 divided by 100, removing the percentage sign, or 0.06. Her number of interest compounding periods, it was compounded monthly, so that means M is 12. So our periodic rate of interest, I, is J divided by M, or 0.06 divided by 12, which gives you 0.005. Next, the ratio C, okay, is the number of interest periods per year divided by the number of payment periods per year. Well, our interest is monthly, so that's 12, and our payments are quarterly, which is 4. So that gives a ratio of 3. So now calculating her equivalent interest rate, P, okay, it's 1 plus the periodic interest rate to the exponent C minus 1, which equals 1 plus 0.005 to the exponent 3 minus 1. And if you calculate this out, you'll get 0.015075. Okay, I kept more decimals here. You could round it just as well. Your answer will be a few dollars off of mine, which, like I said, for these questions is not a big deal. Okay. Remember, you should be getting an interest rate number of less than 1. Okay, if you're getting numbers that are greater than 1, you've done a mistake in your calculator. Last term, N, okay, so she's paying for 10 years, so it's 10, multiplied by 4 payments a year because it's quarterly, so N is 40. So substituting all of these values in, our future value, there's a general annuity due, is equal to 500 times 1 plus 0.015075 to the exponent 40 minus 1 divided by the same equivalent rate of interest, 0.015075. And that's multiplied by this extra interest term, 1 plus 0.015075. Okay? Now again, doing this in steps, if you calculated everything in the brackets, you should get 500 times 54.354 times, adding these two up, 1.015075. Okay? Multiplying all of those out, you come to a final answer of $27,586.69. Obviously, that number will change slightly depending on how much you rounded each of these numbers before. But again, I'm looking for your process. So if you're only off by a couple cents or a couple dollars, that's not an incorrect answer. Okay, that just comes down to rounding. So now let's talk about present value. Okay, so just like in future value, okay, the only difference is we have one additional interest period. So this same 1 plus P term, okay, is added to the end of the present value formula that we used for an ordinary general annuity. Okay, remember the difference between an ordinary general annuity and ordinary simple annuities formula was just that we had this value P, which was our equivalent rate of interest, and it's that formula, 1 plus the periodic interest rate to the exponent c minus 1. So let's look, again, we're going to do two examples for present value. A 3-year lease requires payments of $1,600 at the beginning of every 3 months. If interest is 9% per annum compounded monthly, what is the present value of the lease? So first off, I am asking you directly here for the present value of the lease. So you know it's the present value. Now you just need to figure out which formula it is. Okay. So next, I'm going to look at whether the compounding and interest period frequencies are the same. So, sorry, payment period and interest compounding periods. So your payment periods are every 3 months, that's quarterly, and your interest is compounded monthly. So they're not the same. So that makes it a general annuity. So I write that subscript G. Then, is it our payments at the beginning of the month or the end of the month? Okay, so it's at the beginning. Okay, so the beginning of each period. So that makes it an annuity due. Okay, so knowing that, we start with our formula. Okay, and that was the formula from our last slide. And that's equal to your payment times 1 minus 1 divided by 1 plus the equivalent interest rate P in brackets to the exponent N, divided by, again, the equivalent rate of interest P, times 1 plus that equivalent rate of interest P. That's that additional interest term. So again, on my little sidebar here, we're going to ask, what do we know? So we know our payments from the question are $1,600. Our nominal rate of interest, J, is 9%, which is 9 divided by 100, removing the percentage sign, or 0.09. Our interest compounding frequency, okay, is monthly, which means that M is 12. So our periodic rate of interest, I, is equal to J divided by M, or 0.09 divided by 12, which gives you 0.0075. Next, I'll look at our ratio C. That's the number of interest compounding frequency or compounding periods divided by the number of payment periods. So in this instance, interest is monthly and payment frequency is quarterly, so that's 4, which gives you a ratio of 3. So now, calculating our equivalent rate of interest, P, it's 1 plus our periodic interest rate to the exponent C minus 1. In this instance, 1 plus 0.0075 to the exponent 3 minus 1. So our equivalent rate of interest is 0.02267. Again, this number is less than 1. You should always be getting a number that's less than 1. Okay, this shouldn't be a number greater than 1 and become a multiplier. Okay, because that's going to mean that all of these terms that have exponents will also become exponentially large. Okay, so some of you I've seen obtain very large answers because your value for P was not calculated correctly. Lastly, your value for N. Okay, so it's a 3-year lease. Okay, so that was given in the question. So it's 3 years. And you're paying quarterly, so you're paying 4 times a year. That means in total, you're going to have 12 payments. So if I substitute all these values in, our present value for this general annuity due is equal to our payment, 1,600, multiplied by 1 minus 1 divided by 1 plus the equivalent interest rate, 0.02267, to the exponent 12, divided by the same equivalent interest rate, 0.02267, multiplied by 1 plus the equivalent interest rate, 0.02267. Again, doing this in steps, doing the brackets, we should get 1,600 multiplied by, everything in these brackets comes to 10.404. Okay, again, I rounded there to 3 decimal places, multiplied by 1.02267. So multiplying these 3 numbers together, we get a present value of $17,500. $23.83. Okay? Okay, let's look at a second example. What is the present value of your 20-year mortgage if you are currently making payments of $1,250 bi-weekly at the beginning of each period, and interest is 7% per annum compounded semi-annually? Okay, first item you see, I'm asking specifically for what is the present value. Okay, next is to figure out whether it's an ordinary or simple annuity, or a general or simple annuity, and whether it's an ordinary annuity or an annuity due. So, starting with our compounding periods, okay, payments are bi-weekly and interest is compounded semi-annually. So they're different. That makes it a general annuity. And payments are made at the beginning of each period. Okay, so that makes it an annuity due. All right, this is a good way, again, I know I keep bringing this up, but it's a good way for you to figure out what type of annuity you're dealing with right from the start. So now that we know that, we can start with our formula. Okay, it's equal to our payment times 1 minus 1 divided by 1 plus your equivalent interest rate P to the exponent n, divided by the equivalent interest rate P. And again, since it's an annuity due, you add on 1 plus the equivalent interest rate P to the end of this formula. Okay? Again, doing our little sidebar, what items do we know? We know our payment is $1,250. Our nominal interest rate, J, is 7%, which is 7 divided by 100, removing the percentage sign, or 0.07. Our number of interest compounding periods, M, is semi-annually. Okay, so that means it's 2. So our periodic rate of interest, I, is J divided by M, or 0.07 divided by 2, which gives you 0.035. Okay? Next, our ratio, C, is our number of interest payments divided by our number of payment. Okay, interest periods divided by payment periods. So interest, all right, is semi-annually, so that's 2. And payments, remember, bi-weekly, I've seen a lot of students make this mistake. All right, there's 52 weeks in a year. And bi-weekly means you're paying every second week. Okay, so there's 1 week that goes by that you don't pay, the next week you pay. Okay, so that means you take 52 and you divide it by 2, right? Because you're only paying every second week. So that gives you a total number of payment periods of 26. I've seen answers of 24. I've seen answers of 52. Okay, so remember, every second week, that's what bi-weekly means. So you end up with 2 divided by 26. Okay, and if you calculate that out, you get 0.07692. Okay, so now let's calculate our equivalent rate of interest, P. And it's 1 plus the periodic interest rate to the exponent C minus 1. In this case, 1 plus 0.035 to the exponent 0.07692, and then minus 1. Okay, so the minus 1 is not within the exponent. Keep that in mind. All right. So I've seen a lot of students make a mistake specifically when the exponent is a decimal. All right, so you do the exact same calculation, 1.035 to the exponent. Remember, it's the little symbol that looks like a hat, okay, on most of your calculators, and you just type in the number, 0.07692, okay? And then from that, you subtract 1, all right? And again, you should get an answer that's always less than 1 for this interest rate. So your equivalent rate of interest for this should come out to 0.00265. Okay, remember that one I've seen a lot of students make mistakes on. Your last item is N, all right? So in this instance, for N, we have a 20-year mortgage, and we're making 26 payments a year. So 20 times 26, which gives you a value of 520. Okay, makes sense because a lot of mortgages are bi-weekly, okay, or monthly. For instance, the mortgage I pay is bi-weekly. Okay, so I make 26 payments per year. So substituting all of these values in, your present value is equal to your payments, 1,250, multiplied by 1 minus 1 divided by 1 plus the equivalent interest rate, 0.00265, to the exponent 520, divided by the equivalent rate of interest, 0.00265. Okay. Another mistake I've seen is make sure you carry the appropriate number of decimal places. Okay. So the difference between only having one decimal place and two there, okay, will be a factor of 10. Your last term is 1 plus, again, the equivalent rate of interest, 0.00265. Okay. If you calculate each of these numbers out, you should get 1,250 multiplied by everything within this bracket's terms is 282.06. And then lastly, 1.00265, just adding those two terms together. Solving by multiplying these three numbers together, you get a number of $353,508.81. Okay? So again, keep those factors in mind when you're calculating P and also when you're doing your main calculation that I've circled here in purple. This area in brackets is where I see a lot of mistakes being made, whether it's order of operations or whether it's not carrying enough decimal places by students. So our last item for this lesson, again, is finding what your payments would be, okay? And what that depends on is whether you know the future value or the present value. So that hasn't changed for any of the types of annuities that we've done so far. Again, because these are annuities due, we have an additional interest term, okay? And it's sitting in the denominator, 1 plus P, for both the future value and the present value formula. That's the only change within these formulas, okay? So once you determine in your question that's a general annuity due, you know that you can start with these formulas as a starting point. Again, formulas are always provided to you during tests. So I've got two examples, okay? I'm going to do one with future value and one with present value. Again, walking you through how to determine what type of annuity it is. So what deposit made at the beginning of each month for 8 years will accumulate to $18,000 at 5% per annum compounded quarterly? Okay, again, a couple things to notice here. It's saying what deposit to make, so you know it's a payment question. And now it's to determine what type it is. Okay, so you're paying at the beginning of each month. That makes it an annuity due. And your payments are monthly, interest is quarterly, so they're not the same. So that makes it a general annuity due. Okay, highlighted it here. And it's asking what deposits made if it accumulates to $18,000. That's telling you that $18,000 is your future value. Okay, so you know it's a general annuity due. You're given your future value and you're trying to find your payments. Okay, that's the first set of steps that has to go through your head before you pick a formula. Okay, so knowing that, we're finding payments, knowing the future value. So we're starting with that formula. So our payment is equal to our future value. Again, subscript G for a general annuity. I'm going to put due in brackets, so it's a general annuity due, multiplied by the equivalent interest rate P, divided by 1 plus P to the exponent n minus 1. And all of that is in brackets to be multiplied by that additional interest term, 1 plus P. Okay? So again, sidebar here, what do we know? We know our future value for this annuity due. We know it's trying to accumulate to $18,000. We also know our nominal interest rate, J, is 5%. which is 5 divided by 100, removing the percentage sign, or 0.05. M, our number of interest compounding periods, it's given that it's compounded quarterly. So that means M is 4. So our periodic rate of interest, I, is J divided by M, or 0.05 divided by 4, which gives you 0.0125. Next, okay, we have to calculate our ratio C, number of interest periods per year divided by our number of payment periods per year. Okay, so interest was quarterly, so it's 4, and our payments are monthly. Okay, so that means 12. So this comes out to 0.3, and again as a repeating decimal. Okay, so with this, we can calculate P, our equivalent rate of interest, 1 plus I to the exponent C minus 1, which is 1 plus 0.0125 to the exponent 0.3. I put the bar, remember, a repeating decimal, so that's 0.333 at repeating forever. And then all of that is minus 1. So if you calculate that out, you get an equivalent rate of interest of 0.00415. Okay? Lastly, we need our value for N. Okay? So we know from the question, deposits are made for 8 years, and you're making them monthly. So 12 deposits a year. So your value of N is 96. So substituting all of these values into this formula, your payment is equal to your future value, 18,000, times the equivalent rate of interest, 0.00415, divided by, remember, all this first piece is all in brackets, 1 plus your equivalent interest rate, 0.00415, to the exponent 96 minus 1, times 1 plus the equivalent rate of interest, 0.00415. Okay, so again, doing this in steps, okay, and remember my rounding might be slightly different than yours. Your payment is equal to 74.68 in the numerator, divided by everything in this first large set of brackets, that's the 1 plus p to the exponent n minus 1. So everything in that bracket should come to 0.488 multiplied by this additional interest term, 1.00415. And if you calculate that out, you should get an answer of $152.37. Okay, so that is your payment. Okay, so moving to our last example for this lesson. What monthly payment must be made at the beginning of each month on a 5-year lease valued at $100,000 if interest is 10% per annum compounded semi-annually? Again, okay, we're asking for payment. So now you need to figure out what type of annuity it is. Okay, so payments are made at the beginning of each month. That makes it an annuity due. And payments are monthly. Interest is compounded semi-annually. So they're not the same. That makes it a general annuity due. Okay. The last piece of the puzzle, knowing you're finding payment, is what are you provided? Okay. So you're provided that you have a lease valued at $100,000. Okay, so what that's saying is that's valued in today's dollars, didn't accumulate to that. That's what you started with. So it'd be like if you go and you lease a vehicle, you have a certain value that your vehicle is worth when you start your lease, and you make payments based on reducing the value of that, consistent with how your car or van or truck or whatever it is ages over that period of time. Okay, and depending on the interest rate that's given. So you know that that's present value. So we start with our payment formula using present value. So it's present value, and again, subscript G for a general annuity, and due in brackets to make it general annuity due, multiplied by the equivalent rate of interest, P. And this is divided by, our first term is the term you've seen a lot, 1 minus 1 divided by 1 plus the equivalent rate of interest, P. to the exponent n, multiplied by this additional interest term, 1 plus p. So again, starting with our sidebar, what values do we know? We know our present value is $100,000 for this lease. We also know our nominal rate of interest, J, okay, is 10%, which is 10 divided by 100, removing the percentage sign, or 0.10. M, okay, is our number of interest compounding periods. It's given as semi-annual, so M is 2. So our periodic rate of interest, I, is J divided by M, or 0.10 divided by 2, which gives you 0.05. Next, okay, we have our ratio C, and that's the number of interest payment periods divided by the number of payment periods. So interest is semi-annually, that's 2, and our payment periods, okay, are at the beginning of each month, so that's 12. So 2 divided by 12 gives you 0.16, again, as a repeating decimal, which would be 0.1666, and the 6's would continue forever. So now we can calculate our equivalent rate of interest, P, which is 1 plus the periodic interest rate, I, to the exponent C minus 1. In this case, P is 1 plus 0.05 to the exponent 0.16, again repeating decimal, minus 1. And calculating this value out, you get a value for P of 0.008165. Okay? Lastly, all right, is our total number of payment periods, N. Okay? So it's a 5-year lease, and we're making monthly payments, right? So 5 times 12 gives us a total number of payments to make of 60. So substituting all these values in, your payment is equal to your present value, 100,000, multiplied by the equivalent rate of interest, P, 0.008165, divided by 1 minus 1 divided by 1 plus your equivalent rate of interest, 0.008165, to the exponent 60, multiplied by 1 plus the equivalent rate of interest, 0.008165. So again, doing this in steps, your payment is equal to 816.5 divided by everything in this first kind of large bracket again. You'll get 0.386 multiplied by 1.008165. And if you calculate that out, you get $2,098.15. Okay? So that's it for this lesson. All right. These are your practice problems looking in the textbook. Again, just like lesson 4.1, I did not do the calculations by hand to show you how to find the number of payment periods N. I will show you how to do that in Microsoft Excel in our next lesson. Okay? Thanks, everybody.